Okay, guys, welcome. Today we're going to talk about the divisibility of integers. Okay, so when we say that an integer divides another integer, first of all, let a and b, of course, be two integers. We say that a divides b, or a is a divisor of b, or b is a multiple of a. All three of these mean the same thing, although most of the time we will stick to just a divides b. If there exists some integer m such that a times m is equal to b, right? So again, this is all three of these numbers are integers. So a, m, and b, all three of them are integers. So that's one thing that's important here. And if this is true, we say that a divides b. Okay. Now we denote this by a and then sort of this vertical bar here and then a b, right? That would mean that a divides b. If a is not a divisor of b, then we just put a little strike through that vertical bar there. Now, if a is not equal to 0, and we have that a divides b, then that means that b over a is an integer, right? And of course, you can show that very easily, because if a divides b, that means that for some integer m, a times m is equal to b. And if you divide both sides by a, you get that b over a is equal to m. And we said that this is true for some integer m. So we know that m is also an integer, right? So b over a is. Now, if a is bigger than 0 and a does not divide b, we can still divide b by a, but we will pick up a remainder term, which we'll call r, right? Now, r satisfies, of course, the fact that it's greater than or equal to 0, and of course it would equal 0 if a divides b, and if it doesn't divide b, then it would be that r is at least 1, but of course less than a, because if it is a, then that means that it divides it. Now, we say that the quotient of the division with the remainder is q, then we have that b is equal to a times q plus r. And again, q here is an integer, it's just some integer, right? And of course, r is your remainder. And of course, a and b were sort of the original given integers. And this, of course, is going to be extremely important when we think about division with a remainder. Okay. Now, let's look at some examples. We want to know, what does it mean if 2 divides a? Well, if 2 divides a, then this means that 2k times, so some integer k is equal to a, right? So for some integer k. Right, well, what does it mean if we can write a as 2 times an integer? That means that a is even. Right, now if 2 does not divide a, on the other hand, that means that 2k is not equal to a, right? And of course, for some k, that's an integer. And of course, this means that that you could have something like 2k plus r is equal to a. And in this case, your r would have to be 1. So this shows that, long story short, a is odd. And then, of course, part C is interesting, because this would say, by definition, 0 times k is equal to a, right? And this says that if 0 divides k for any k, well, 0 times anything is 0. So we get 0 is equal to a, right? So if 0 divides our number, then the number has to be 0. Okay, now let's do some proofs. So in this first one, we have that if a divides b and b divides c, then a divides c. Now this one's easy to show, so I should be able to squeeze it up here. Now a divides b means that a times m is equal to b for some integer m. And b divides c means that b times k is equal to c for some integer k. Okay, and we want to show that a divides c. So can I write a times some integer L equals C? Well, of course, yeah, because if we say, I'm just going to come down here now, we have that AM is equal to B and BK is equal to C, right? So what we can do is I can substitute B equals C over K right here. And I'm going to have A times M is equal to C over K, and I'll just multiply both sides by K. And we get A times MK is equal to C, but MK is an integer, right? Since if you multiply two integers, you get another integer, right? So then that tells us that A divides C. Okay, let's look at part B. So for part B, we have if A divides B and A also divides C, then A divides the sum B plus C and the difference B minus C. Well, if A divides B, that means that AM is equal to B. If A divides C, that means that so AK is equal to C. And we want to show that A divides B plus C, right? Or i.e. AL is equal to B plus C. Right, so something like that. Well, if I look at B plus C, we know that that's equal to AM plus AK. So then we can write this as A times M plus K. But the sum of two integers is an integer, so we can call this L. Right? So then we get that A divides the sum. Right? And of course, for the difference, it would work the same way. Just put minus here. Okay? For part C, we have if A and B are both greater than 0 and A divides B, then A is less than or equal to B. Okay? So we have that A divides B, and they're both greater than 0. So this means that A times K is equal to B. Right? Now, if both A and B are positive, that means that I'm multiplying A by some integer to get a positive number, right? So of course, what we're trying to show here is that A is less than or equal to B. So since this is positive and this is positive, K must also be positive. And since K must be a positive integer, the smallest it could be is 1. So K is less than or equal to 1. So then that means that if I were to have A times K, that would be greater than or equal to just A. And of course, that is equal to B. Right? So then we get that A is less than or equal to B. Okay, and then finally, let's see, so it's probably going to take a minute here. So the last one that we want to prove is that if A divides B and B divides A, then either A and B are the same or they're opposites. Okay, so once this gives me my space, we can prove this. So, and we're going to prove this, of course, the same way. We just want to say that based on the definition of divides, we have A is equal to, A times an integer is equal to B, and B times another integer is equal to A. Okay, so any second here. Sometimes when the file's bigger, it takes a little bit longer to give me the space. There we go. Okay, so then for part D, A divides B means that AM is equal to B, and B divides A means that BK is equal to A. Right, so now what we can do is let's go ahead and let's make a substitution here, right, because we have two equations. So let's say that we have B, which is now AM, times K is equal to A. So then what's going to happen is we're going to get that AMK is equal to A. And if AMK is equal to A, then I can plug that in to this side right here, and I will get that BK, sorry, not to this one, to this one, right? And then we're going to get that an A, wait a sec, let me backtrack this a little bit. Okay, just to be a little bit more clear. Okay, so let's take this first equation, and we have the AM is equal to B, and I'm going to substitute this B for this AM right here. So that's going to give me an AM times K is equal to A. Right? Now, if I want to get A by itself, let's move the AMK over. And then what's going to happen is that we're going to get that 0 is equal to A minus AMK. So then we can factor, and we'll get a 1 minus MK times A. Now again, let's see, so we weren't told, okay, so A could be 0, that's fine. So here we get that A is equal to 0, or 1 minus MK is equal to 0. This is the key part here. Now, if 1 is equal to MK, and MK are both integers, then either M and K are 1, or M and K are -1. Right? And of course, this will give you the possibilities that either, if you now look at either one of these two equations, you'll then get A is equal to B, or A is equal to -B. Okay, so that's a couple of those proofs. All right, now for the last one of this section, we're going to let R be the remainder of B divided by A. And we'll assume that C divides A and that C also divides B. And we want to show that C divides R. So first we need to handle this first part. Let R be the remainder of B divided by A. Well, then that means, based on what we talked about before, this is A times some Q plus R. Okay. Now let's look at if C divides A. Well, if C divides A, that means that CM is equal to A. And if C divides B, that means that CK is equal to B. Now, if we plug that stuff in here, I get a CK for B is equal to A, which is CM times Q, plus R, right, which we don't know about yet. Now, however, we're told that that we want to show that C divides R, right? So we want to show that C is equal to some integer L times R. Sorry, C times some integer L is equal to R. Now, what we're going to do is I'm going to move this CMQ over, and I get that CK minus CMQ is equal to R. And of course, I can factor out a C here, and I'm going to have K times a MQ, right? And of course, that is equal to R. Now, if I multiply or subtract two integers, I still get another integer. So I've shown that C times some integer gives me R. So of course, that allows us to say that C divides R. All right, so that concludes this video on divisibility of integers. I hope you enjoyed, and I'll see you next time.